Hey guys, welcome to this video. This is just a video of me doing designing a building on Staad. As you can see, this is the rough sketch that I just made a few seconds ago. It's just a simple shed of having four columns at the corners, and this is the rough footing and the slab that it'll be designing right now. This is just for demonstration purpose, and this video is going to be including all that I do. It's having minimal editing and all the defects and all the mistakes that I'll be committing while making this video are all inclusive into it. So it's gonna be a long video. So let's get started. First of all, let's start Staad Pro. Staad Pro. Okay. I'll be creating a new project. Let's name it Trial 1. Okay. Design with me. Okay. Yeah, the meters, kilonewton. Okay, next side. Add a beam. Okay, finish. This is what the Staad environment looks like, and here is what the default grids come into action. I'll be just deleting it. I don't need the grid. Now what I'll be doing is I'll be just taking the center line from this plan. You see, this is the plan that architects usually provide to the consultants. Now let's find the coordinates. How do we find it? Okay, coordinate system. So first of all, I'll place the UCS at this position right here. Okay, over here, and align the UCS. Once you're done aligning the UCS, what you need to do now is just take this ordinate command. This is 0 0. 5 6. Okay, now we're done with y-axis, and now we'll be starting with the x. This is 0 and this is 5. So what I need to do now is I'll just be getting to here. I'll need to insert the nodes. Okay, node over here. As you can see, the axis over here, x, y, and z-axis is coming out of the plane. So I'll be inserting the plane over here like this. Top view. I'm on the top view right now. Okay, let's start. So first of all, first coordinate is at 0 0 0. Okay, the next one will be at 0 and 5, and the third one will be at 0, 6, and fourth will be 6, 5. Fourth will be at 5, 6. Hey, am I doing something wrong? Oops, it's all jumbled up. Bad. Let's delete all these nodes. Check, delete. Yeah. Let's start again. This is 0 0. This is 0, 5. This is 5, 0. Okay. Oops. Then this is 5, 0 0. Right. We're done here with two nodes. Now about the above parts. It is 0, 6. 0, 6, and the other is 5, 6. 5 and 6. Done. All four nodes are visible. Now let's check out the other view. These are only two nodes. From minus z also two nodes. Then other from the top y. Then the isometric view again. As you can see, the xy plane and the y is for the height. Now right now we have established the four ground points. Now what I'll be doing is, as you can see, here is a footing, and the footing extends below about DLI, and it's about 0.5 meters. I guess I made it. Yes, it's roughly 0.5 meters. So firstly, what I'll be doing is I'll be joining this plane beam right now. Just pick up this command. Oh no. This would be a great mistake right now. What I'll be doing is just select all these nodes, and where is it? Translational repeat. and this will be the y-axis. The spacing would be about 0.5 minus 0.5 because it should go down. You can see these points have came down now. Now as these nodes are already connected, I'll be just going to this geometry, put it here, connect beams along. What we're having is right now x-axis, the members are created. Now again the geometry, connect beam along the axis. Okay, the plinth beams have been connected. Now I'll be selecting these. I'll just take a side view of this and select this entire portion over here. Or what I'll be doing is, okay, let's proceed with this only. Constellational repeat 1, and the height over here is, I guess it's about 3 meters. I just drew it a few minutes ago. Okay, it's 3 meters. We'll take it as 3. Okay, oops, I forgot to mention the axis. Okay, yes, I'll be saving. Save. Okay, next part is, it should go up in the y direction, 3 meters. Okay, it's done. Points have moved up. You can see the isometric view. It seems some kind of error. Some kind of error has occurred. See, I'll just join this beam again using this. I've done with the beam right now. I'll be selecting the nodes. I'll just take the select button. To select the beam, you need to actually select more than half of it so that it is actually continue. Now translational repeat y-axis 3 meters. Okay, you can see it's made 3 meters above. This is the down view from down. This is view from the top. This is view from the side. As you can see, it's available now. Now what I'll be doing is just take the node selection and connect command along beam along y. Okay, 4 members are created of this for this. Oops. Correct beam along y. Okay, our model is ready right now. All I need now is to give a few properties like the footings, the solid reaction that will be coming from the down. So I need to go to command and where is it, loading, and geometry is done. Okay, where is it? Support specification. Now for this I'll be taking fixed end support. Okay, let's add those. Now take this view. Let's select this part. Okay, fine. Let's see if it's assigned to all now. Okay, done. Now I have assigned the supports to this. I can see the model also. Supports have been assigned. Now what I need to do is just assign a few material properties like the dimensions, because you can see the dimensions over here. .23 by 0.23. Where do I get it right now? Okay, material properties. No, it's member property, prismatic, and over here rectangle 0.23. Okay, done. Material is concrete itself, and then add, boom, it's added. I'll be considering all the elements to be rectangle in all shapes. You see, select over this. Everything is of the same shape. Okay, done. Now all the members have been assigned the properties. Now you can see the this is what it looks like after assigning a property, and here is what you get the rendered view of it. See, the frame is ready right now. Frame is completed. Okay, close this. Now what we need to do is assign a few loadings to this member, all these members. So there are a few commands, loadings, and primary load. Okay, close. And okay, over here I'll be selecting this, add self weight, member load, area load, member load. Okay, let's take an area, try giving it an area load. Physical area load is over here, and the care that would be about assuming 3 kilonewton per meter, and this is negative, else it would take it positive. It will be applying it in the reverse order. Okay, load 3. Now, okay, assign. And over here also. Save. This beam, and this beam. Okay, assign. See, the loads have been assigned. The 3D model is ready. All we need to do now is just analyze this beam. I'll try and run analysis. Let's see if it works out. Error in output analysis. Go to output file. Let's see what comes there. You see, as I've analyzed it, I got a few errors while analyzing it. I'll just be deleting this load. Instead, what I'll be doing is, okay, load case 1, add flow load. This is what I was missing actually, and the flow load would be about 3 kilonewton meter for the minus 3 kilonewton. This is very important. What is it doing? Let's analyze it and see what happens. Again, I am getting some error. Finish in command, and this one is other. Okay, let's see if it's there's still some error in the flow. I'm deleting this load right now. Delete it. I'll just be doing right now. Next. Okay, close. Plate load. Yeah, let's check out if this works out. Minus 3 kilonewton per meter. Okay, add, close. Now let's assign something. Oops, it's not working right now. I'm not getting why it's taking like this to be. First part is okay. This is how the load distribution count looks like and appears to be. But why is it that it's assigning it somewhere else? Okay. See, I did this. What's happening? Take this to go. Add. Okay, let's design the beams for. Okay, we take a play floor load. This is about 2 kilometers. Y range, X range. What is this about? Let's see it if it's look. Then add. Okay, it's X range. It's applied the load to that side. Okay. So we have to actually find out this. Define it for the X and X and Z direction. Let's delete this out. Excuse me. Add. Let's just assume the distribution of load to be directly on the beam. And what if we just add up the loads to the beam? What would happen? Just uniform force. Okay. And the uniform force, let it be about 12 kips kilonewton per meters minus 12. On y-axis, add, closed. Assign to cursor. Yeah, save this, save. Over here. Or this beam, or this beam, or this beam, and this beam. Okay. Load is in this. Oh, I lost 2 of the beams. Assign to this as well as this. Signing is done. Let's try analyzing the figure. Again, we have some sort of error. Okay. Analysis. Okay. Sustain. Once you would have observed that these options are now activated. This actually shows how the shear force and bending moment of that area of the figure is. Let's check this out. And this is the deflection of Z. This is the sagging. Sagging is actually not visible right now. So what we can do is we can just scale the figure. Get to animation, deflection, animation, and apply. Let's see if we can see. No, it's very difficult to visualize that. Oh, deflection, displacement, it's 1. Let's see what happens. It's too much. Put it 100. Apply. Okay, it's visible right now. You can see the deflection of this part now. We'll try animating it. Okay, let's take the displacement to be 50. Oops, it's too much. Okay, Okay, let's try an animation. Okay, it's deflection, apply. Okay. Under those loadings, verify what happens. You can see this is buckling downwards, and the sides are also getting outside. See, load has been released and it comes back to its position. Load is added, it buckles down. So this is how you get the analysis for beam. Now let's just try designing it. Where do we get it? These are the loads and deflections. You can see over here. Now I'll be just starting the concrete design for it. Okay, I don't need this stuff here. Okay. Oops, something had started. See all these deflection, shear force, and bending moment animation. Okay. Get back to the modeling. Now what we need to do is design for this command. Where do we get the design option? Just a minute, I'll be back. Let's start with the design now. Complete design. Okay. Oh yeah, we have to select a few parameters, and like we are using this ASCI code, and in India we use IS456. Okay. To define parameters for these are the parameters. Yeah, I'll not be getting into details of this. So just all these category parts are important, Rest of the member heights and max. Width of the cross section to be used. Using this. Supported line, torsion and all invested. If you don't select this, it actually takes its own values. Depth of the section to be used. Maximum size of reinforcement, maximum size of secondary reinforcement. Okay, all these is what I want to define right now. Design of beam, design of column. Yeah, take off. Design beam. This is a beam, this is a beam, this is a beam, this is a beam, this is a beam. You need to actually specify what is a beam and what is not a beam. So these are the beams. Now the columns. Beam cursor. This is the column. This is the column. This is also a column. It is just because it doesn't know what is a column, which one is a column. It actually designed for that. What do you call it? Designed for the geometry. So you need to specify how are you gonna do that. Now I'll just keep it in the speed designs analysis has been done. Everything is completed right now. I'll be having just by clicking at this column. I know this is giving me the details like the cross section, total span, and depth of the column, property, material, and all being used over here. Load cases and all. Shear force, how the shear is being developed on this. Like what is the shear at this section, what is here, what is here, and deflection, how the section is being deflected. Let's select over here. Activity design, give you the design for that column, for that beam as well. So the column beam design. You check the column. Column. The complete design is complete, I guess. Clear on the analyze, okay? Yeah. Let's check out for this warning that it gave me previously. Zero, 4 warning. Video output file. See over here, warning limit percentage C, reinforcement limit exceeded. The length of the member cross section is it's using FE415 M30 grade of complete. So actually what you can do is the cover was also pending, so I'll give a cover of I don't want to define that. Reinforcement is 6 allows I'll take it as a 500. Consider minimum intensity about an SPSB, consider being to the 230 only. Take it as default. This is what this is percentage of longitudinal reinforcement allowed. I'll be fixing it to 3. So maximum distribution method NMD reinforcement FY shear reinforcement, and that is also 500. the concrete strength, composite strength. I'll be taking it as 28 of the Yes, this will be limited to about 230 only. I got 4 warnings again. Now let's see what happens. This is the design section. Distribution is also given for 4 bars of 10 mm. The distribution. So this is how you do that. See, for the column I need columns are assigned. Just design these columns. The column is having 4 bars. 5, 6, this was just trial and error. I was actually right now learning Staad, so that I would just try designing a simple structure having 4 beams and 4 columns. Okay. Thanks for watching.